Hello, algebra students. Mr. Lawrence here, and this is going to be a quiz prep video. We're going to have our quiz on Monday. If we should have a snow day Monday, then the quiz just won't happen second quarter because my grades are due Wednesday, and we don't have normal classes Tuesday or Wednesday because of the Career Center field trip. So as long as we have school Monday, we'll have the quiz. If we don't, the quiz will end up being next Thursday, but won't count until third quarter. Okay. So first of all, we're going to have to know how to simplify rads. And remember, perfect squares are super important in helping us simplify rads. And you can generate your perfect square list really easily. You just start with 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. You might be wondering how high you should go. Do you have to go all the way to 400, 20 squared? No. You have to go as high as the number. Okay, you don't have to go over the number. So I'm trying to simplify the rad 338. I'm going to go pretty high, but I don't have to go all the way to 20 squared or 400. So let's do 6 squared, 7 squared, 8 squared, 9 squared. Oops, silly mistake there. 9 squared, 10 squared, 11 squared, 12 squared, 13 squared, 14 squared, 15 squared, 16 squared, getting ahead of myself, 256, 17 squared, 18 squared, and I can stop here, okay, because 19 is going to be 361. All right, now I'm going to go through and determine if any of these, starting at the high end, are factors of 338. Well, I know 324 isn't. I know 289, if I double it, I'm already in the 500s. 256 doubled is in the 500s. It can't be. 225, this doesn't end in a 5 or a 0. There's no way that's a factor. I'm not sure about 196, so I'm going to take 338 and divide it by 196, and I'm going to get not an even number. It doesn't go in evenly. Then I'm not sure about 169, so I'm going to do 69. Oh, and it goes in twice. So this is 169 times 2. So now I've got two choices. I can think about a problem like this and then break it down into 13 times 2, and then do my dating thing and say, hey, the 13s leave the house, go on a date, 2's left at home without a partner. There you go, 13 rad 2. Or I could have thought about it this way. I could think about it as the square root of 169, or the rad of 169 times the rad of 2, just right from there. The rad of 169 is 13. We don't know the rad of 2. It's an irrational number. And notice I get the same number either way. I don't care how you think about it as long as you can get the right answer. Notice I'm not touching a calculator. Okay? Now, I could check on my calculator. I could take the rad of 338. Oops, hold on a second. The rad of 338. And it's approximately equal to 18.384777631. And now I can do 13 rad 2, and I get the same exact decimal, 18.384777631. Now you understand that's not the square root of 13 rad 2 or rad 338. It's just a decimal approximation. It is very close, but there is no actual square root of that number because it's irrational. All right, so you can do it either way, or if you have your own way, that's fine too. All right, 96. I don't need to worry about any of these numbers here because they're all more than 96. So I'm going to start at 81. Is 81 a factor of 96? No way. 64? 49? Ooh, I'm not sure. I'll check. Let's do 96 divided by 49. Nope, doesn't go in evenly. 36. Let's divide by 36. 96 divided by 36. Nope, doesn't go in evenly. 25. No, 25 is not going in evenly. 16. Maybe. Oh, it goes in 6 times. So I've got 16 times 6. Now I can do the dating thing if I like. Right? And then the 4s leave the house, go out on a date. 6 is left at home. Or I can think about it this way. Rad 16 times rad 6. Rad of 16 is 4, or rad 6. And notice I get the same answer either way. All right, now we're also going to need to estimate square roots. And I've got a little work down here already. I need to estimate the square root of 41. Well, I know 41 is between the perfect squares 36 and 49. So I listed them all out here. I know that the square root of 36 is plus or minus 6. Square root of 49 is plus or minus 7. I'm going to find the median of this data. And I think there's 14 numbers here, right? 49 minus 36, 13 plus 1, right? 14. So 1, 2, 3, 4, 5, 6, 7 is right there. And so that's going to be plus or minus 6.5. What number would that be? Well, that'd be the square root of 42.5. Let's take the square root of 42.5. It's about 6.519. And we're saying it's approximately 6.5, 6 and 5/10. So that's a pretty good estimate. Now, if it was right at 42 or right at 43, I would just go ahead and kind of adjust this answer. But since it's a little bit away, I'm going to go ahead and find the median of the first half of the data. And so let's see, there were 7 over here, so it's 1, 2, 3, 4. So there's the median, 39 on the nose, and I'm going to suppose that it's about plus or minus 6.25. How did I get 6.25? Well, it's halfway between 6 and 6.5. Now, if you don't know, you can average them. Add 6 plus 6.5, and then divide by 2, and you'll get 6.25, 6 and 25/100. All right, now I'm going to change colors so my work stays a little separated. Now, I'm going to try to get the median here. It's a little bit weird because those are there, but it looks kind of like the 41 is maybe in the middle, doesn't it? That's not exactly the middle. It's probably going to be skewed over here a little bit. Maybe I should, yeah. Having a hard time deciding. I got 2 full numbers. I got 1 full number. That's a space, full number, space, full number, space, full number, space. So space, full number, space, space, full number, space. Yeah, we're going to go red 41. So I'm going to average these two. All right, I'm going to average these two. So I'm going to take 6.25. Oops, I lost my marker. I'm going to take 6.25. I'm going to add it to 6.5, and I'm going to divide by 2. And I think I'm going to come up with like a 6.378 or 375 or something. Hold on a second here. Plus 6.5, and I'm going to divide by 2. Yeah, 6.375. All right, so I'm going to check here real quick. 41. Oh, wow. Look at that. My estimate was that it would be about 6.375. The calculator told me that it was about 6.403. I'm pretty close there, aren't I? Let's take the 6.403 and subtract 6.375 from it, and I get off the difference. The difference is 0.028, not even 3 pennies. That's a pretty good estimation. Now, you don't have to do that. I mean, if you said about 6 4/10, that'd be a pretty good guess. Okay? All right, so you saw I found the median, and then I found the median of the first half of the data, and then I found the median of that, and I just kept narrowing it down. How did I find the medians? Averaging. All right, let's try one more. Now, this is rad 142. Now, this one, I'm not going to write them all out. I know it's between 121 and 144, but that's a lot of numbers to write out. That's 24 numbers. I know that the rad of 144 is plus or minus 12. Doesn't the rad of 142 have to be pretty darn close to 12? I'll bet you it's going to be 11.9 something, or maybe 8, high 8s, like 88. I'm just going to say about 11.9. So this is my estimate. Let's see what the calculator tells me. calculator. Remember, there is no square root of 142. The calculator is just giving me a number that could be close to it. It's approximately this number. And they got 11.916. If I subtract that, the difference is going to be 0.016. I'm off by less than 2 pennies. And because it was such a big number to take the square root of, 142, I didn't want to list all the perfect squares out, or all the square roots out. It would take too much time. I'm just going to kind of reason it out. All right, now, if you're in second period, seventh period, or eighth period, you can stop watching. Okay, if you're in first period, you need to keep watching. All right, we've still got to learn about operations with rads here. We've got this rectangle, and we're going to find the perimeter, and we're going to find the area. Now remember, the perimeter usually involves addition. The area involves multiplication. With addition, I'm going to think like terms, right? Multiplication, I'm going to be thinking some type of distribution, probably. Probably, not always. All right, so let's find the perimeter first. The perimeter is going to be the distance around the rectangle. Now look, there's no excuse for not knowing this. You're in 8th grade, you're in Honors Algebra 1. We've done perimeter area problems. It's time to learn it. There's no more excuses. You're too intelligent to say, I don't get it. You do get it. You just don't want to get it. That's the problem. All right, so before I actually do it, I'm looking at this rad 45 thinking it can be simplified. So I'm going to simplify the rad 45 like we did in the first problem. And I know the largest perfect square I can find in there, the factor is 9. So rad 45 is going to simplify to 3 rad 5. So when I go to do my perimeter, I'm not going to use 6 plus rad 45. I'm going to use 6 plus 3 rad 5. All right. Now, perimeter is really easy. All I have to do is add up my rational numbers, then add up my irrational numbers. Now, let's do the rational numbers first. I see a 6 here. Since we're doing perimeter, I know there's a matching 6 over here that's not written down. So 6 and 6 is 12. My perimeter has 12 for its rational number. Excuse me. Now I'm going to do my irrational numbers. And let me see here. Let's see. I've got 3 rad 5 right here. But over here I have 2 rad 5. So what do I have if I put them together? I've got 5 rad 5s, don't I? But there's another 3 rad 5 over here and another 2 rad 5 over here. So now I have 10 rad 5s. I have 3 rad 5 and 2 rad 5, 5 rad 5, and then another 3 and 2 rad 5s. So that's 10 rad 5 total. So I'm going to have 12 plus 10 rad 5 in its perimeter, so it's in inches. And there you go. All right, now I'm ready to do area. Now area is simple. I'm going to take the 2 rad 5 and I'm going to multiply it by 6 and by 3 rad 5. This is the distribution. Now, notice I did not use the rad 45. I used the 3 rad 5. It'll be so much simpler. So now I'm going to distribute. And I've got 2 rad 5 times 6, which would be 12 rad 5. Here, I have 2 times 3, which is 6. But I have rad 5 times rad 5, which is 5. And 6 times 5 is 30. So the area is going to end up being 30. Always write the rational number first, plus 12 rad 5. And then since we're doing area, it's inches times inches, so I'll be in inches squared. Okay? Yeah, when I multiply the coefficients, then I multiply the rads, and then I simplify if possible. All right, here's one more. If you want, why don't you try this one on your own? Pause the video and see if you can get it right. Find me the perimeter and area. All right, here comes my solution. First thing I'm going to do is I'm going to simplify this rad 18. Rad 18 is going to be the same as 3 rad 2. So I'm going to think about this as 3 rad 2. All right, so I'm going to do my perimeter, and I'm going to add up my rationals. I got a 2 there, and there's going to be a 2 down here, right? Okay, and then I also have a 4, but there's going to be a 4 over there. So it looks like I have 8, 10, 12. So my perimeter is going to have a 12 for its rational number. Now let's add up the irrationals. I know Colton likes to multiply by 2. He likes to take 5 rad 2 plus 3 rad 2, which is 8 rad 2, right? And then double it, which would be 16 rad 2s. So plus 16 rad 2. And it's in centimeters. There we go. All right, now let's do our area. So area, I'm going to take the quantity of 2 plus 5 rad 2 times the quantity of 4 plus 3 rad 2. And notice, even in this situation, I write my rational number first. Okay, now I'm going to double distribute. So I'm going to do 2 times 4, and I'm going to get 8. I'm going to get 2 times 3 rad 2, which would be a 6 rad 2. Okay, here I'm going to multiply 5 rad 2 times 4, which I think is going to be a 20 rad 2. And then I've got to do 5 times 3, which is 15, rad 2 times rad 2, which is 2, so this part here becomes 30. Now the 30 and the 8 are like terms, and the 6 rad 2 and the 20 rad 2 are like terms, so I'm going to combine like terms. So my area is going to be 38, 8 plus 30, and plus 26 rad 2s. There's 6 rad 2s, 20 more rad 2s, there's 26 rad 2s. And that'll be centimeters squared. And there you go. Okay, that's your video to help you over the weekend. Good luck on your quiz. We'll see you Monday. Have a good night, everybody.